Imagine a planet covered in plant life, air that we can breathe, and oceans that cover a large portion of the surface. Does this sound familiar? It should, because it is the planet that we live on, Earth. But what if we were to make another planet to match this description? The process of making a planet more Earth-like is called terraforming. Terraforming is a theme for many science fiction books, but is it possible to do this? To take a barren planet like Mars and turn it into a home where we can live without spacesuits? Terraforming is not an easy process, but it is possible. It will take many centuries to change a planet into something like Earth where we can live normally. Before continuing, I'd like to mention that I got most of my information for this video from Isaac Arthur and his video on the same subject. The things that we would need on a planet to make it like Earth is breathable air, water, and temperatures that we can live on. Also, some other things that will be useful are day lengths that are not too long and gravity that is like Earth's about 9.8 meters per second squared. All these things are possible to change on a planet, but the cost of doing so would be astronomical. It would take billions of tons of even the lightest air to make an effect on a planet. Air on Earth is made from about 20% oxygen and 80% nitrogen. Water is a molecule of 2 hydrogen atoms and 1 oxygen atom. So to get both breathable air and water on a new planet, we would need to transport these 3 gases. Another option for getting water onto a planet is to redirect ice asteroids to collide with the planet. Lastly, to change the temperature, we could use greenhouse gases like carbon dioxide to heat a planet, as well as giant shades to block the sun and cool the planet. Where would we get these resources? It's not like we could just bring them from Earth. Attempting to fill a planet with these resources would severely drain our own supply of them. Because of this, we must look towards other planets, moons, or asteroids to find these resources and bring them to the planet. So, where would we get them? For oxygen, we could use the oxygen that has been sequestered in rocks of Mars. Of course, to get access to this oxygen, we would need to melt the rocks that contain the oxygen. Even if used efficiently, this would take thousands of years to get enough oxygen for a small ocean. Nitrogen to make breathable air can be found in the atmosphere of Titan and Venus. Titan is a moon of Jupiter and is more likely to be a better choice because there is low gravity on Titan than most planets. Because of this low gravity, it would be easier to build a mass driver, a tall structure that peeks through the atmosphere and would launch capsules of the required airs. Hydrogen would be found in Jupiter's atmosphere. Jupiter's gravity is much heavier than Earth and is a gas giant, so we are unable to build structures on it and would not be able to efficiently launch from the surface. Instead, we would use a skyhook, which would use electrodynamic tethering. The idea of electrodynamic tethering is to use the magnetosphere along with the rotation of a weight and payload attached to each other by a cord. Finally, we need greenhouse gases like CO2, which is most of Venus's atmosphere. And seeing as Venus's atmosphere is nearly 100 times thicker than Earth's, it has CO2 to spare. Not only will this help heat colder planets like Mars, It will also cool Venus as it loses its greenhouse gases. Mass drivers can also be used, but seeing as the planet's surface is molten, we would need to use floating mass drivers. Mass drivers supported by blimps so that it floats and doesn't need to touch the ground. Unfortunately, just getting these resources onto the planet would not be enough to terraform. There are several ways that an atmosphere around the planet can be lost. Both heavy impacts from meteorite strikes and radiation can send the atmosphere you just built back into space, undoing the work you have just done. The reason this does not happen on Earth is because Earth has a natural magnetic field. The core rotates slightly faster than the rest of the planet, creating this magnetic field. The field blocks the radiation from the outside. To make a magnetic field for a planet, the most obvious option would be to restart the core by melting it using nuclear bombs. However, using such a method would probably be more costly than creating an artificial magnetic field. You could make the field by using solar-powered satellites that would orbit the planet, creating magnetic fields around them. Changing a planet's gravity is not possible with current technology. We could replicate it by using spinning habitats, but we also do not know if long-term low gravity will be harmful to people. Terraforming high-gravity planets would be much harder because there are obvious ways that too much gravity is harmful, such as breaking bones whenever you trip. Changing daylight is possible, but like melting the core is much harder than artificially replicating it using a combination of mirrors and shades that orbit the planet. There are some other ideas that would be useful for terraforming, but we do not have any idea how to make them or if they are possible. One idea is artificial gravity. This would allow us to choose more planets that have high or low gravity and artificially make gravity reasonable there. Another idea is wormholes, which would make transportation much easier as we could transport anything directly without wasting time on traveling and likely prevent the transport containers from being damaged. The last idea I would like to bring up is nanotechnology. With nanotechnology, we could send them to the planet where they would process the rocks there and produce gases from it. These are all just ideas because we do not have any of these. Although we may not get the chance to live on other planets, it is very possible that in the future someone will. But if we start soon, who knows? Maybe your grandchildren and their children will live there. Although there are ways, these ways take large amounts of time and money and more money than we can afford to spend.